Right. This section is applications in the cloud. I think there is only a couple left in the prompt engineering, and then would be course summary. Let me see if I can. The relatively short looks like. I'll see if I can finish them all. If not, I still gonna break them up. Let's see how it goes. Yeah. So far in this course, we have provided an introduction to Google Cloud and explored the options and benefits related to using virtual machines, networks, storage, and container in the cloud. In the final section of the course, we'll turn our attention to developing application in the cloud. We'll begin with Cloud Run, which is managed compute platform that runs stateless containers via web request or pub/sub event. We'll begin our Cloud Run. Cloud Run is serverless. That means it removes all infrastructure management tasks so you can focus on developing applications. It's built on Knative, an open API and runtime environment built on Kubernetes. It can be fully managed on Google Cloud, on Google Kubernetes Engine, or anywhere Knative runs. Cloud Run is fast. It can automatically scale up and down from zero almost instantaneously, and it charges only for the resources used, calculated down to the nearest 100 milliseconds, so you never pay for over provisioning resources. Cloud Run Developer Overflow is a straightforward 3-step process. First, you write your application using your favorite programming language. This application should start a server that listens for web requests. Second, you build and package your application into a container image. Third, the container image is pushed to Artifact Registry, where Cloud Run will deploy it. Once you have developed your container image, you'll get a unique HTTPS URL back. Cloud Run then start your container on demand to handle requests and ensure that all incoming requests are handled by dynamically adding and removing containers. Because Cloud Run is serverless, it means that you, as a developer, can focus on building your application and not on building and maintaining the infrastructure that powers it. For some use cases, a container-based workflow is great because it gives you a great amount of transparency and flexibility. Sometimes you're just looking for a way to turn source code into an HTTPS endpoint, and you want your vendor to make sure your container image is secure, well configured, and built in a consistent way. With Cloud Run, you can do both. You can use a container-based workflow as well as a source-based workflow. The source-based approach will deploy source code instead of container image. Cloud Run then builds the source and packages the application into container image. Cloud Run does this using BuildPack, an open source project. Cloud Run handles HTTPS serving for you. That means you only have to worry about handling web requests, and you can let Cloud Run take care of adding the encryption. The pricing model on Cloud Run is unique, as you only pay for the system resource you use, while a container is handling web requests and a granularity of 100 milliseconds, and when it's starting or shutting down. You don't pay for anything if your container doesn't handle requests. Additionally, there is a small fee for every 1 millisecond request you serve. The price of container time increases with CPU and memory. A container with more vCPU and memory is more expensive. You can use Cloud Run to run any binary as long as it's compiled for Linux 64-bit. Now, this means you can use Cloud Run to run a web application written using popular languages such as Java, Python, Node.js, PHP, Go, and C++. You can also run code written in less popular languages such as COBOL, Haskell, and Perl. As long as your application handles web requests, you are good to go. Many applications contain event-driven parts. For example, an application that lets users upload image. When that event takes place, the image might need to be processed in a few different ways, like converting the image to a standard format, converting the thumbnail into different sizes, and store each new file in a repository. The function could be integrated into the application, but then you have to provide compute resources for it, whether it happens once a millisecond or once a day. With Cloud Run functions, you write a single purpose function that completes the necessary image manipulations and then arrange for it to automatically run whenever a new image is uploaded. Cloud Run functions is a lightweight, event-based, asynchronous compute solution that allow you to create small single-purpose functions that respond to cloud event without the need to manage a server or a runtime environment. These functions can be used to construct application workflow from individual business logic tasks. Cloud Run functions can also connect and extend cloud services. You build to the nearest 100 milliseconds, but only while your code is running. Cloud Run functions support writing source code in a number of programming languages, include Node.js, Python, Go, Java, NetCore, Ruby, and PHP. For more information about supported specific version, refer to the runtime's documentation. Events from cloud storage and PubSub can trigger Cloud Run's functions asynchronously, or you can use HTTP invocation for synchronized execution. Okay. Oh, it's already lab. There's a lab, and the lab will run about 1 hour. Okay. Let me see. I think we'll take a short break here. Okay, let's push through it. Let's start the lab. Okay. Cloud Run is a managed compute platform that enables you to run stateless containers that are invocable via HTTP request. Cloud Run is serverless. It abstracts away all infrastructure management so you can focus on what matters most, building great application. Cloud Run is built from Knative, letting you choose to run your containers either fully managed with Cloud Run or in your Google Kubernetes engine clusters with Google Run on GKE. The goal of this lab is for you to build a simple containerized application image and deploy it on Cloud Run. Objective: in this lab you'll learn enable the Cloud Run API, create a simple Node.js application that can be deployed as a serverless, stateless container, containerize your application and upload to Artifact registry, deploy a containerized application on Cloud Run, delete any unneeded image to avoid incur extra storage charges. Okay. setup and requirement. We have, okay, click login. These we can skip. Activate shell, click continue. Okay, so we can start here. Okay, now we start here. Activate. Google Cloud Shell is a virtual machine that is loaded, or we have used Google Shell before. And then you see this little icon here, Activate Cloud Shell, and we can click on it and it will pop up here. Click on Authorize, and we can maximize this as such. G-Cloud is the command line tool for Google Cloud. It comes pre-installed on Cloud Shell and support tab completion. You can list active account name with this command. Okay, we can try this. List. It's active Google account, moadigital@gmail.com. To set active account, run Google. To set the active account, run gcloud config set account. Sample active. Okay, we already active, so. And we can do the next one. You can list the project ID with this command. We can do Google Cloud config list project. Okay, so this is the last project that we used for storage. Lab 531591 is the Cloud Storage Lab. Basic command. Yeah, we probably want to create a new one. Let's do a new one. Let's minimize this and then click on select a project, create a new project. We're gonna stick with 531, I think it's 599, and click create. Take a couple minutes to finish. Okay, set here. You're working on 599. Okay, we can close this one. We can select this one. You're working in lab 531599. Okay, that's good. And then now we click on activate Cloud Shell again. Now, so that this time this shell command is related to lab 531599. And if we were to run this command again, gcloud config list project, you should see 531599 as well. There you go, project. And it also put see it here. Okay, good. Core basic Linux command. Below you'll find a list of find a reference list of very few basic Linux command which may be included in instruction or code block for this lab. We have a make directory list, apt-get, move path, present working directory. Okay, task 1. Now we're moving on to the hands-on task. Enable the Cloud Run API and configure your shell environment. Okay, for Cloud Shell, enable the Cloud Run API. Okay, so we're gonna do gcloud services enable run Google APIs.com run.googleapis.com. Okay. If you are asked to authorize the use of the credential, do so. You should see the successful message similar to this one. Okay. Operation finished successfully. Okay, good. You can also enable API using APIs and services section of the console. Okay. Set the compute region. Okay, we're gonna do gcloud config set compute /region double quote all capital region. API not enabled for project. Would you like to enable? Retry this. Will take a few minutes. Okay, yes. Currently is enabling service compute.google's apis.com on project on the current project. I kind of don't understand here. So I run this project. Enable is to enable the run. Oh, okay. Oh, it's different. This is the run on Google APIs. This is to enable Cloud Run, and this is to enable compute engine. Okay, that makes sense. Okay, now it's good. Now we can try it again. Warning, property validation for compute escape. Update property compute engine. Updated property compute /engine. Okay, now we can create location region. Okay. And now task 2, write a sample application. In this task, you will build a simple Express-based Node.js application which responds to HTTP request. In Cloud Shell, create a new directory named Hello World, then move your view into the directory. Okay. We can do world. Okay, now we are in Hello World folder. Next, you'll be creating and editing files. To edit files, use nano or the Cloud Shell code editor by clicking on the Open Editor button in Cloud Shell. Creating the package.json file, then add the following content to it. Okay. Since we do the nano, can we do the editor? No. Or open editor. Let's try this. Oh. Oh, it's opened up an editor. Going to hello world folder. Oh, this looks like a visual code to me. We don't need this. We don't need this. This is new. Okay. We also have the image from last lab, but I thought it doesn't show me which project I'm in. Supposedly I'm in the new project 599, but how come 599 has this? I don't trust this yet, so let me go back here. So we'll do nano package.json file. Oh, no, nano. Okay, and then I'm not gonna type this. Oh, I'm gonna copy and paste in here. I can do Control X. It will ask, say modify buffer. Yes. I'm going to type yes, and then enter, and then do a list of the file, and then the package JSON file is listed. And now we do the nano index.js. Okay. Again, I'm not going to type all the code in, just going to be copy and paste, same thing. Yes, enter, listed, and I can see the index file here. This code creates a basic web server that listens. While we are here, why don't we just show it here? Okay, so this code creates a basic web server that listens on the port 8080 defined by the port environment variable. Your app is now finished and ready to be containerized and upload to artifact registry. Okay, so we can do contain X, Control X. Okay, you can use many other languages. Start with Cloud Run. You can find instruction for Go, Python, Java, PHP, Ruby, Shell Script, and other from Quick Start Guide. So we're not gonna go over that. Only concentrate on Node.js for this task. Task 3: containerize your app and upload to artifact registry. To containerize the sample app, create a new file named Dockerfile in the same directory as the source file and add the following content. Okay. Do nano Dockerfile and then copy over Node from Node 12, Node.js version 12, slim version, work directory. Copy this over. We're gonna do a run npm install only for production. Copy files over. The last command line npm start. Okay, do the same thing. Control X, Y, enter, list it. It should be here, Dockerfile. Okay, good. Now build a container image using Cloud Build by running the following command from the directory containing the Dockerfile. Note the Google Cloud Project environmental variable in the command, which contains your lab ID. Let me see, lab project ID. Okay, which we know what that is, which is lab 531599. Okay, we can do copy and paste, and then we will modify this. Wait, should that be already? I don't have to modify this. Let's try not modifying it. Let's see how it works. Cloud Build is a service that executes your build on Google Cloud. It executes a series of build steps, where each build step is run in a Docker container to produce your application container or other artifact and push to artifact registry all in one command. Okay, so we're gonna build submit tag GCR.io project. Okay, let's see what it does. So creating temporary archive of 3 files, total 1.3 kilobyte before compression, uploading top of all this file, all the directory to blah 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 blah. API Cloud Build not enabled on project 531599. Would you like to enable and retry? Yes. So Cloud Build need to be retried. Okay, I'm gonna take a break here, and then when we're back, it should be enabled. We'll continue on that. Okay, we're back. Authorized Cloud Shell, authorized. Let's do that again. It's connecting. Okay, we're back. 513599, which is the right one. Okay, so we go back to gcloud build submit tag gcr.io / Google _cloud_ project hello. Whoa. Wait, we have to 1 second. I think we have to go back to the Hello World folder first. Okay, because you won't see it. Oh, there you go. Should go to Hello World, and then I'll just copy this. Create it. Okay. Once pushed to the registry, you'll see success message containing the image name. The image is stored in artifact registry and can be reused if desired. Okay. Now it looks like it's pushing the repository, the images to the registry. So we'll wait till we're finished. Okay, success, everything success, green. Okay, and then we can do a gcloud container images list. Okay, that's great. This is the okay, perfect. Let's clear this. Oh, okay, we have done this. Register gcloud as a credential helper for all Google supported Docker registry. Okay, so we can go ahead to do this. Configure Docker. Okay, a long list of credential helpers may cause delay running Docker build. We recommend passing the registry name to configure only the registry you are using. gcloud credential helper already registered correctly. Okay, so let's clear again, give it some room. Okay, to run and test the application locally from Cloud Shell, started using the standard Docker command. Okay, Docker run the port 8080 gcr.io Google Cloud project hello world. Okay, let's run this. Okay, and bind for okay. Let me see. Is it talking about? Okay, no. It's already. Oh, it's already successfully. Okay, cool. In the Cloud Shell window, click on Web Preview and select Preview on port 8080. Preview. Let's see. I think it might be this one. Web Preview. Preview port for port 8080. Okay. Hello world. So this is what we created earlier. So it's successfully. This should open up a browser window showing the hello world message. You can also simply use curl Google. Okay, we can do that one. Let's just try it. And then here's the message. Okay, now task 4, deploy to Cloud Run. Deploying a containerized application to Cloud Run is done using the following command, adding your project ID. Okay, and just paste service name, and when prompt, confirming the service name by pressing enter. Okay, please enter numeric choice or text value must exactly match list item. Okay, and then you may be prompted, do you want to enable this APIs to continue? I didn't get this. Location region is location. We specify a region. Okay, we can do 35. Okay, it's deploying container to Cloud Run service. Hello World in Project Lab 531599, region US East 1. Deploying. Okay, we'll wait till we're finished. So I didn't get to see this prompt yet, if there is any. I'll be back when it finishes. Okay, it's done. It says here, okay, deploying, done, okay, done. Service Hello World has been deployed and is serving 100% of traffic. Service URL app. Okay, so this is the URL that I believe it would be open to the public, and then we can just click on it, and again this is public URL. Okay, you can now visit your deploy container by opening in any browser window. Good, congratulations, you have just deployed an application package in a container image to Cloud Run. Cloud Run automatically and horizontally scale your container image to handle the receive request, then scales down when demand decreases. In your own environment, you only pay for the CPU memory networking consumed during request handling. For this lab, you use the gcloud command line. Cloud Run is also available via Cloud Console. Okay, so from the we can close this. On the navigation menu in the serverless. Let me check. Where is the serverless? Cloud Run. Where's the serverless? I don't see no serverless. Where's the serverless? Let me close the shell first. In the lab. Where is it? Dashboard, serverless. Services Cloud Run. You didn't say. Okay, let's do it again. Navigation menu. This is Kubernetes engine. Cloud storage. There's storage, obviously, or Cloud Run here. There's no serverless. Okay, we can just. I missed it earlier. Let's see here. You can see Hello World service listed. Services here, and that's good. Task 5, cleanup. While Cloud Run doesn't charge when the service is not in use, you might still be charged for storing and building container image. You can either decide to delete your Google Cloud project to avoid incurring charge, which will stop billing for all the resources used within that project, or simply delete your Hello World image using this command. Since I'm not gonna come back to this, I'm most likely going to I will delete this. Gcloud container image delete gcr.io world. Okay. Do you want to continue? Application will delete the tag and image identified by the digest above. Yes. Delete it, delete it. To delete the Cloud Run service, use this command. So let me do this as well. Yes. Oh, I think I have to go into the Hello World directory. Wait a second. How come I delete the image here? I did this. I didn't do this. So how come refresh? It's still here. So why is not deleting it? Do I need to Oh, I think it's 35, right? It's 35. So US is 1. Okay, good. Now it makes sense. So if I refresh here, so actually I have to put this in. I didn't do it. Okay, so when I refresh, the service Hello World is deleted. I think, yeah, I think that's it. This is it. End your lab. When you have complete lab, click end lab. Congratulations, you have completed this lab. Blah 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 blah. Okay. Next quiz. Okay, let's see if we can finish the quiz too. Which scenario is best suited for using Cloud Run instead of Cloud Run function? Generating thumbnail for images uploaded to a cloud storage bucket. Resizing image on demand when requested by user through a web interface. Hosting a dynamic web application that allows users to upload and share photos. Sending email notification whenever new document is added to a specific folder in Cloud Run. I think it's this one. Hosting a dynamic web application that allows users to upload and share photo. Yeah, I think so. Which is, these statements about Cloud Run functions are correct. Select Cloud Run 3 Cloud Run functions. So multiple choice. Require server or VM to be provisioned. Can be used to extend cloud services. Is a scalable functions as a service platform. It looks can only be invoked by sending HTTP request. Okay. No, this is wrong. Can only be invoked by sending is integrated cloud logging. What might a Google Cloud customer choose to use Cloud Run function? Cloud Run function is primary way to run. No. Their application contain event-driven code that they don't want to provision compute resources for. Their application has the legacy monolithic structure that they want to separate into microservices. %66%. Which one I got wrong? So this is correct. Oh, so I think it's this one. Let me see. Yeah, that's correct. Application contain event-driven code that they don't want to provision compute resources for. Yeah, I don't know why I picked this one. It shouldn't be. Yeah, okay, got it. All right, so container in the cloud is in the book. We're moving on. The next is application in the cloud. Oh no, application in the cloud is in the book. Next would be prompt engineering. But we'll stop here. We'll do another one for the next section.